Learning target 21 says I can calculate the mean, variance, and standard deviation for the sum of the outcomes of repeated experiments. So in these problems, you're going to know something about the mean, the variance, and the standard deviation for some kind of an experiment, and it's going to ask you, suppose you did that experiment 100 times or 200 times, and you added up all the results, what would be the new mean, the new variance, and the new standard deviation? So in this problem, you're given the statistics for a normal number cube, so a number cube with the numbers 1 through 6 on it. And the question says, suppose you rolled 100 number cubes and added the results, what would be the mean, the variance, and the standard deviation for the sum from those 100 rolls? So let's think about a simpler question first. Let's imagine instead of rolling 100 number cubes, let's imagine that we just roll 2. And then imagine that you added up the results from those two number cubes. So what would happen would be the new mean for the sum would be the mean for your first number cube plus the mean for your second number cube. So in this case, you would just get 3.5 plus 3.5. Now imagine that you rolled a third number cube and you added up the results from all three of your rolls. Your new mean for the sum would be the mean for the first number cube, the mean for the second number cube, and the mean for the third number cube, all added up. So as you can see, if we do this 100 times, what's going to happen is we're going to have the mean for a single number cube added up 100 times. So instead of doing 3.5 plus 3.5 plus 3.5 over and over again, we can just take that 3.5 and multiply it by 100. And if we do that, we're going to get 350. Now the same sort of thing works with the variance. If you do an experiment twice, the variance for the sum of the results of those two experiments will just be the two individual variances added up. So if we rolled two number cubes, the variance for the sum would just be 2.917 plus 2.917. If we rolled three number cubes and added up the results, the new variance would be 2.917 plus 2.917 plus 2.917, and so on. So if we rolled 100 number cubes and added up the results, what would happen would be that we would have our original variance, 2.917, added up 100 times. Another way of doing that would be 2.917 times 100. And if we do this, we get 291.7 for our variance for the sum of the rolls of 100 number cubes. Now, this is very, very important. You cannot do this with the standard deviation. It turns out this does not work with the standard deviation. So please, please, please do not do this. Do not say that the standard deviation is 1.708 times 100. Please do not do that. That's not correct. What we need to do instead is we need to just calculate the variance first and then take the square root, because we know that the variance is, the standard deviation is always the square root of the variance. So you cannot not just take the standard deviation and multiply it by 100. What you have to do first is find the variance and then just find the square root of the variance. So in this case, we're going to take the square root of 291.7, and you end up getting about 17.079. So that's the standard deviation for the sum of 100 number rolls. To apply this to another problem now. So in this problem, it says, suppose your score on each learning target retake you attempt has the following statistics, where you either get a 0, a 1, or a 2. 2 is completely right, 1 is you made a mistake, 0 is didn't really show much for conceptual understanding of the topic. And suppose that your score has these statistics. So you have a mean of 1.5, variance of 0.25, and standard deviation of 0.5. And the question is to find the mean, variance, and standard deviation for the sum of your scores on 5 retakes. So if we do 5 retakes and each of them have a mean of 1.5, the mean for the sum will just be the mean for 1.5, added up 5 times, or in other words, multiplied by 5. So to find our new mean, we're going to take our mean, 1.5, and multiply by 5. We get 7.5. We can do the same sort of thing with the variance. The variance for the sum of the scores on 5 retakes is just going to be our original variance, 0.25, multiplied by 5. If you multiply that out, you'll get 1.25, and that's going to be your variance. Now you cannot do this with the standard deviation. You cannot take your standard deviation 0.5 and multiply it by 5. What you need to do instead is just take the variance that you just calculated and take the square root. So we're going to take the square root of 1.25. And we're going to get about 1.118. So let's just quickly review what we do to find the mean, the variance, and the standard deviation for the sum when you do an experiment a bunch of times. So we know that to find the new mean, we're going to take the mean for each experiment and basically just multiply it by however many times you do the experiment. Same sort of thing works for the variance. You're going to take the variance for each individual experiment, multiply by however many times you do that experiment. This does not work for the standard deviation. You cannot just take the standard deviation and multiply by the number of times you do the experiment. Instead, what you have to do is just find your variance first and take the square root of whatever variance you get.